Hello everyone, thank you very much for having me today. So I'm Thomas Bezy, first year PhD student at the Paris School of Economics. And today I'm going to tell you about the French insurance system against natural disasters that is very unique and that can be insightful when thinking about how to insure against natural disasters. So first, let me tell you about how the system works. So let's imagine that you have two types of households, households located in low risk and high risk areas. They all pay housing insurance premiums to to private insurance companies. Then the law in France forces private insurance companies to give 12% of these amounts to Caisse Centrale de l'Assurance, which is a public reinsurance company that will take care of natural disaster losses. So basically what it means is that the cost of being insured against natural disasters in France is 12% of your housing insurance premium, no matter your risk of exposure. So if you're in a risky area or in a safe place. This is a system that has many advantages. The first advantage is that insurance is affordable in France, and that coverage of insurance is very large. So you have 98% of households which are covered. But then when natural disasters take place, people are reimbursed, so you have households located in high-risk areas that get more than people located in low-risk areas. And the second step is that after private insurance company reimburse households, they get reimbursed by the public reinsurance company. So in the end, private insurance companies do not bear the cost. It's really the public insurance through the contributions of households. But then what it means is that this system leads to income transfers from low-risk areas to high-risk ones, because you have the same price of insurance for everybody, but different levels of benefits. And so the question I want to ask in this paper is which income groups actually benefit from the current system? Is it high-income households helping low-income ones to rebuild their homes, or is it low-income households paying to rebuild the secondary homes of high-income households? That's the question I want to ask in this paper. So what I want to do is first estimate the level of contributions by income group. So being able to say, okay, in this time you pay that much in housing insurance. And then estimate the amounts received by each income group, so which will depend on exposure, and then I come to the difference between both, and I get how much it gets net transfers. So first, insurance contributions. The thing I want to show here is that this cap fee, so this fee on housing insurance premiums, is regressive. That's something that you can see just here. So this is based on survey data. So I have access to survey data that tells me by income by income level how much people pay in housing insurance. I'm able to show that you pay much more in housing insurance over the disposable income. So how much does housing insurance weighs on your budget? So this amount is much larger at the bottom of the distribution than at the top. We have in my sample, I have 3.6% of the population that pays more than 5% of their income in housing insurance. So I mean, housing insurance can represent a very large cost for some part of the population. And the question that I want to ask here is it correct that we have such a regressive tax? I mean, when we see that actually insurance can weigh a lot on the budget, and it seems like a fair question. So first, the contributions are regressive, and I will derive contributions from this survey data. Then exposure to extreme weather events. So to compute how much people benefit from the system, so how much they are exposed, I use this data set from this administrative data set in France that covers all dwellings. So I have access to the geolocation of every dwelling in France and to the income of every renters, owners, etc. And I am able to track secondary homes as well. So I'm able to see which homes are secondary homes, which will be relevant for the analysis. For now, I just did the analysis for year 2017. It's a pretty heavy process, and I mean, for now, it's just 2017, but later on, I plan to do it for several years. I have two types of exposure. So exposure to floods and exposure to subsidence. So these are the two main risks that we find in France. So floods, everybody knows what it is. Subsidence, it's a bit different. This graph explains what is subsidence. If you don't know what it is, it's when the soil is made of clay. When there is a drought, the floor goes down. The ground goes down, and when it rains, it goes up. And these movements can actually damage houses. And this is a huge phenomenon in France. Floods represents around 50% of total losses, and sometimes 50% as well. So this is a very big phenomenon. And so I cover these two types of events. So this is just to illustrate what I do with an example in southern France. So in blue, you have the map of exposure that they have, map of exposure to floods, and every red point is a dwelling. So as I said, I have access to every dwelling in France. And in black, you have the flood protections. I have them on my maps. So which means that on the maps I am able to they take into account flood protections. So it's not like just satellite data. It's really data based on on-site studies that take into account flood protection. So it's a good quality data for floods. And I have different levels of intensity, so high risk, medium risk, low risk, etc. And I check my results for different levels of intensity, and I already observe the same results. These are the results. So on the x-axis, you have household disposable income by percentile. And on the y-axis, you have the number of dwellings exposed to coastal flooding. So here I'm just talking about coastal flooding. And when we take into account only primary residence, we see that there is a decreasing trend with respect to income. So what does it mean? It means that the first victims of natural disasters, of floods, are low-income households. They are more often located, their primary residences are more often located in risky areas. But when we take into account primary residences, the graph completely changes. It looks like this. So this is for coastal flooding. So this is like, I don't know if you've ever been to France, but this is like Mediterranean coast. So like lots of secondary homes there and exposed to coastal flooding. Where we have approximately the same number of buildings that are in the blue area and the red area. Which means that when we take into account secondary homes, where we have an increasing trend. Coming back to my first points about who benefits from the system, it looks like if we have a system that doesn't differentiate primary and secondary homes, we will have a system that will benefit more the top of the distribution. So this is for coastal flooding. And here I show the distribution of secondary homes in France. So you see that it's pretty unequal. You have the top 1% that owns 10 times more secondary homes than every percentile up to the middle of distribution. So yeah, it's very much concentrated, which explains the results I had just before. When I consider not only coastal flooding but river flooding, I have this. So this is less striking, but still we observe the same trend. Decreasing trend with respect to income when we take into account primary residence, and increasing trend when we add secondary homes. And this is for subsidence I was telling you about. We observe approximately the same trend. Then what I do is that I have how much people pay, and I have how much people are exposed. But then exposure is not exactly the same as the damage you would experience, right? So for this, I do the damage function. I don't really have the time to go into the details about this, but I'm right now in discussion with insurance companies in France, trying to build a better damage function that will take into account past insurance data. But so far now, it's a damage function that is based on housing surface and exposure and some other characteristics that I have access to many characteristics like altitude of the dwelling, many characteristics to improve this damage function. But just to show you how it looks like with this basic average function, these are the net benefits by so net transfer by disposable income. So by this side, the disposable income. And so you see that the bottom distribution, as they pay not much in housing contribution, and they are still exposed via their primary residence, they get more than the middle distribution, but it's really the top 10% that gets much more than the middle of the distribution. So yeah, that's so this system in the end benefits the bottom, but mostly so to conclude, first I want to underline that the French system is like has many advantages. As I said, it makes insurance affordable, which is a problem in many countries. I mean, in many countries, it's like the take-up rate is very low. In France, it's 98%. So I mean, that's a great advantage. But on the other hand, it's a system that is financed through a tax that is regressive. So the bottom 10% pays 75% more than the top 10% as a share of the income, so in terms of weight in their budget. And the main victim of natural disasters are low-income households, so via their private residence. But the insurance actually targets more the top of the distribution via their single amount. So, and in the end, I conclude that net transfers are, I mean, the net transfers are twice higher for the top 10% than for the middle, 70-80%. So even if the system has an advantage, as I said, the affordability, well, we could think about trying to improve it, maybe trying to think about different system for secondary homes, these types of thing. And also, I think this is interesting not only for France, but because I mean there are lots of discussions. I mean, we talked about this morning. Because the talk with Augusto, the fact that in San Diego and California, you have some kind of similar system in which it's not a flat rate, but it's something that is similar that enables lots of households to be covered. Well, in France, we have a system that goes one step beyond, and that actually allows really all households to be covered. Well, it's not enough. We want to have a fair insurance system to cover everyone, but we should also think about who we are covering and how we are covering them. Anyway, that's all.
Quick question. Here's an effect which may make it even more aggressive than you think. So consider equilibrium house prices. So without insurance, if you were living in a risky area, you'd have to pay, a lower price for your house. But with insurance, then you take away that risk premium or partially offset the risk premium. And since the second home seems to be the main thing, there seems to be an additional subsidy working through the equilibrium prices in the housing market, which I think would make the results potentially even stronger. So you could look at house prices and see how they react to the kind of risk.
Yeah.
I don't know if you thought about that. I know with your income measure before or after housing costs, because obviously that would then also affect income because your mortgage will be different depending on that implicit subsidy.
Yeah, so for house values, yeah, I have data on house values. Actually, I just didn't explain it for now, but I have it, and I plan to do something as you are describing with it. So there is data in France for covering all France for house prices, so it's feasible. And then your second point was, sorry.
So is your income pre or post housing?
Yeah, so it's pre, it's raw, but yeah, also I think it would be very interesting to have this graph, but as a ratio of housing costs and not only like income, I mean, here, because I mean, it would be interesting to see how much like these insurance contributions weigh on housing costs generally and not only income. Thank you.